Hello everyone, welcome to Physics and Rapid YouTube channel. In this channel, you will get concepts related to physics as well as PYQ of various examination. In today's video, I am going to solve previous year question paper related to the particle physics. Let us start with the first question. The question which was asked in the year 2020, the question says, muon positive gives rise to electron positive plus neutrino of electron. That is, I am going to rewrite the question. Muon positive gives rise to, you can call it as positron plus antineutrino of positron, or you can call it as a electron, is forbidden because the charge is not conserved, lepton number is not conserved, isospin is not conserved, and the baryon number is not conserved. These are the options given. Let us start one by one. Let us see whether the charge is conserved or not. Charge is represented by the symbol Q. On the left hand side, we have muon, which is having a positive 1 plus 1 charge, and the positron, which is having a plus 1 charge, and the neutrino, it doesn't have any charge. So change in charge, that is a delta Q, which is equal to 0. So the charge is conserved. Next, we shall go to the lepton number. We need to uh, look at the lepton number of an electron and the muon separately. So first I am taking the lepton number of an electron. So muon we will not consider, it is 0. Electron, that is positron. Electron is the lepton. Antiparticle of the electron is positron. So lepton number of an antiparticle will be minus 1 plus antineutrino of an electron. So it is positive. So minus 1 plus 1, it will be 0. Lepton number is also conserved. Next, we will be moving to the lepton number of a muon. On the LHS side, we have a muon. On the product side, we don't have a muon. So muon number is not conserved. It is, we can see easily. Yes, muon, it is antiparticle. Antiparticle lepton number will be minus 1. So antiparticle of muon, it will be minus 1. Electron we will not consider here, so the lepton number of muon is not conserved. It is not equal to 0, it is equal to minus 1. So lepton number is not conserved in the first question. I hope everyone understood. Let us move to the next question. The decay of photon gives rise to electron plus photon is weak interaction, not allowed, strong interaction, or electromagnetic interaction. First, we will rewrite the reaction, whatever they have given in the question. Let us solve now. Okay, first we need to see whether the charge is conserved or not. Proton is plus 1 and the positron is plus 1, and the photon doesn't have any charge, it is 0. So delta Q is 1 minus 1 will be 0. Charge is conserved. Next, we will be moving to the lepton number of an electron. So the lepton number of an electron, proton, it does not belong to the lepton, so it will be 0. It will belongs to the baryon. So positron, antiparticles, it is minus 1, and the photon, no, it is 0. So the lepton number is, the lepton number of the electron is not conserved, so I can say the lepton number is not conserved. The lepton number is equal to minus 1, it is not equal to minus 1, so it is not conserved. I can say the reaction is itself not allowed. Why means, in the weak interaction, listen to my words carefully. In the weak interaction, the strange number will be either 0 or plus or minus 1, and isospin will not be conserved, and the third component of the isospin will not be conserved. In the strong interaction, the strange number will be 0, isospin is conserved, and the third component of the isospin is also conserved. The charge, lepton number, baryon number, rest of the things are conserved. Okay, next, in the electromagnetic interaction, strange number is equal to 0, Isospin is not equal to 0. The third component of the isospin is equal to 0. That is, it is conserved. And these are the laws to be done while under the conservation. Okay. If in the case the charge is itself not conserved, the lepton number is itself leaving this, the lepton number is itself not conserved, and we get the strange number to be equal to more than plus or minus 2 plus or minus 3, at that time I say my reaction is not allowed. I can say my reaction is not allowed or my reaction is forbidden. Okay, here the lepton number is itself not conserved, so I can say this given reaction is not allowed. Okay, let us move to the next question. Weak interaction respect the following conservation law. Here I have clearly measured the weak interaction respect the charge. Okay, so it will not conserve the strangeness, even the parity, combined charge conjugation and parity, only it will conserve the charge. Okay, yes, let us move to the next slide. And the theory behind the today's calculation I have done in the previous video. You can go and check in my channel. Okay, yes, let us do the question. Choose the correct statement regarding the spin and the isospin of the Epron. This Epron come under the baryon. Epron, we have a fourth particle under this. This is a sigma Epron. Under the sigma Epron, we have a subdivision, that is sigma negative particle, sigma positive particle, and sigma zero. I can say my isospin, which is equal to 1, and the third component of the isospin, it will be different for all these three particles. They have not asked it in the question. And spin is this eprons belongs to the baryons, and baryons belongs to the comes under the fermions. This will comes under the fermions. These fermions which will be having the spin half integral multiple, not the integral multiple, half integral multiple, like this 1 by 2, 3 by 2, and 5 by 2. So from the options I can clearly see isospin is 1 and the spin is up. The third option is right option. And the classification also I have explained detailedly in the previous video. You can go and check there if you have any doubts. Let us move to the next question. Which of the following is an antiparticle of itself? Neutrino, it as an antiparticle, that is antineutrino. Cation, that is pi cation. K cation, in the sense we have a K positive 0, K negative, and K negative 0, like that. K mesons, it is called as neutron, it is a neutral particles. So I can tick to the option A, that is a eta meson is the right answer. It is the antiparticle itself. It will come under meson itself. Under meson we have a pi meson, K meson, and the eta meson. The antiparticle of eta meson is eta meson itself. Okay, next let's move to the next question. Strange particles are characterized by. It was asked in the year 2016. From the definition, it is a straightforward question. From the definition, I can tick the option A, that is fast production and slow decay. Strange particles are nothing but this is the property of the particle under the strange numbers. Okay. The question says like this: which of the following decay is forbidden? We need to, I'll detailedly explain the option A how it will work, then you can do yourself. Yes, let us take, this question is solved by taking the help of the options. Forbidden in the sense the reaction is not allowed. Okay, uh, not allowed in the sense it does not conserve charge as well as the lepton number or the baryon number. If the rest of the things, if these three things are conserved and the rest of the thing is not conserved, means the reaction is allowed, but we have a different names, that is a weak interaction, strong interaction, and electromagnetic interaction. Let us take the first option, that is muon negative gives rise to electron plus antineutrino neutrino of a muon plus antineutrino of a electron. So let us see whether the charge is conserved or not. Yes, it is minus 1, gives rise to minus 1. Neutrino and antineutrino, it doesn't have any a charge, it is 0, 0. Okay, so the charge is conserved, that is delta Q, I can say it as 0, right? On both the sides of the equation, it is minus 1 and minus 1. Next, we shall move to the lepton number conservation, that is lepton number of a electron. Muon, it will be 0. For electron, it is plus 1, and muon, it will be 0, and the antiparticle of a electron, it is minus 1. So the lepton number of electron is also conserved, so that is equal to 0. Next, we will be moving to the next conservation, that is a lepton number of a muon. Lepton number of a muon, in the sense it is muon particle, it is plus 1, electron will not come here, and the uh, neutrino of a muon, it is plus 1, electron will not come here, so the lepton number of muon is also conserved, it will be 0. So if these three things are conserved, means I can say my the reaction is allowed, right? The rest of the conservation law, no need to see, because what they have asked in the question, whether it is which of the reaction is not allowed, so it is allowed. Okay, let us take the D option. Okay, let us take the D option. It is clearly visible that the reaction is not allowed. Let us see now. I am writing the reaction. Let us see the charge, conservation of a charge. It is pion positive, gives rise to electron positive, that is a positron, electron negative, electron negative. Okay, so here it is plus 1, minus 1, and here it is minus 1. So we have delta Q to be equal to minus 2. That is not equal to 0. The charge is itself not conserved. I can say my option D is the right answer. That is the not allowed. Let us move to the next question. The reaction photon gives rise to electron positive plus electron negative cannot takes place because it violates. Let us write the reaction first, and um, let us see one by one. Charge. A photon doesn't have any charge, it is 0. Positron, it will be plus 1, and the electron, it will be minus 1. Plus 1 minus 1, it will be 0. Charge is conserved. Okay. Next, we have a lepton number of the electron. We need to see. Photon, it does not belongs to the lepton, so it is 0. uh, Antiparticle, it is minus 1. Electron is the particle, it will be positive 1. Lepton number of the electron is also conserved, it will be 0. Next, we have a parity. Parity conservation is also equally important. For positron, we have a negative minus 1, and for an electron, we have a positive 1 parity. Whereas even the photon has the parity, that is minus 1. So I can say my here in this question, my parity is not conserved. Okay, let us move to the next slide. And we have the question which was asked in the year 2013. Parity is violated during. For this, the theory is under weak interaction, parity is violated. Okay, weak interaction, parity is violated. Under strong and electromagnetic interaction, EM means electromagnetic interaction, parity is not violated. Okay, here parity not violated. So in the weak interaction, parity violated. So which option is correct now? Option B is correct. In the previous slide, we have one a reaction I showed you. No, photon gives rise to electron positive, that is electron negative, positron and electron. This is weak interaction. This is the example for weak interaction. In the weak interaction, parity is not concerned. You can answer like this also. Okay. Let us move to the next question. Isospin doublet is formed by. This is a very interesting question. We have, what is, first we shall see what is isospin doublet. Isospin doublet is nothing but which has two particles that have the same spin and similar masses but different in their electric charges. Let us take with the correct option and we shall study. The correct option is proton and the neutron. It which has a same spin, right? From the baryon octet structure or the baryon decouplet structure, we can see proton and the neutron which has a spin half, right? And which have a similar mass, right? Proton has a similar mass and the neutron has a similar mass. That is same mass, same spin, same mass, but differ in their electric charge. Proton has a charge positive one, whereas a neutron, it is a neutral, means the charge is 0. So I can say the option D is right answer. Thank you.